My name is Chris. I am a scientist here at Nov. My job, I am one of the principal operators on two different electron microscopes and one advanced light microscope. Typical day, we meet first in the morning as a group, say, okay, here's what today's project is. Usually it's an ongoing project from the previous day, but just to touch base, figure out where we are, where we're going, if we're meeting our timelines, and from there, pretty much we disappear onto our instruments and do our work. Come out for lunch, work on our instruments, and call it a day. Rather convoluted. I initially left high school. I wanted to be an electrical engineer. That's what I was going to go do. I went to Stevens Tech for 2 years to find out that I really didn't want to be an electrical engineer. So from there, I said, well, what do I like? What has a whole bunch of diversity in it that I could really sink my teeth into? And biology sounded about right. So from there, I went to William Patterson, finished with a bachelor's in biology, and ended up here about 1.5 years later. Compared to some of my friends, no. Compared to a lot of people around here, it's about the same. Most of us didn't start here first. We sort of found our way here and stayed here for a good long time. I was in my 3rd year at William Patterson. I, just on a whim, took a course in electron microscopy. It was open, I needed the credits. I said, I'll take it. It was 2 o'clock in the morning. I was on the electron microscope in a dark room, sitting back, looking at the pictures I just took, and the electron microscope all lit up and with everything on going, I can do this. I like this. I want to go do this. And never really looked back. So that was my career goal from that point on. And it took 3 years to get where I am now, but I finally got here. It's much faster paced than I would have expected. In high school and even in college, they sort of insinuated that research biology, which is really what we are down here, sort of had this relaxed, think about it, almost academic pace to it. It's really not. Everything moves quickly. There's tight timelines, there's pressures of a normal business here on top of the science of what we're doing. So that's probably been the biggest difference to really get used to. And it did take some getting used to coming out of academia into, oh yeah, you can, they'll finish it, it'll work, it might not work. You will make it work. My favorite part of my job is a lot of electron microscopy, there's a tremendous amount of preparation work. You can spend 3 weeks doing prep work for something before you actually know if it works or not. My favorite part is after you've done all that prep work, when you first get it into the scope and you look and it's just the way you wanted it, you say, it's like, that's it. That is my favorite part of this job. A good imagination. You need a solid background in biology. Computers doesn't hurt. Actually, with the way most biology is going now, computers is almost mandatory. But problem-solving skills and imagination for the not immediate answer, I find is probably one of the more critical things to have around here. Not everything we get handed to us is very straightforward, and we're often asked to come up with novel solutions to things that might require thinking into the engineering fields, thinking into the art fields, thinking all sorts of different places. Even if you're not thinking about a career in biology, give it a look. We encompass a lot more than cutting up frogs and boring pictures of slides. We do computers, we do graphic arts, we do high voltage electronics, we do everything. It's actually, a lot of it's right in this room I'm sitting in. So even if you think, oh, biology, that's dead frogs and dead squirrels and stuff, it's a lot more than that these days.